And we're live. Hello, I'm Deborah Byrd, and we're here today to talk about how scientists are working to keep us safe from asteroids colliding with Earth. But first, this news. At 10 UTC today, the sun blasted an X9 flare. It was the biggest flare of solar cycle 25 so far, and the 15th largest since June of 1996. It came from a sunspot region called AR 3842, which had fired an X7 flare on Tuesday. There's already sun stuff headed our way that was blasted out by the X7 flare. And now there's more sun stuff coming from the X9. So that could mean a big auroral display, maybe starting late today, maybe tomorrow morning, but hopefully extending through Saturday. So more about that at earthsky.org. We have a daily sun post there that has information about it. And join us tomorrow at the same time for an update during our Friday Sun News of the Week. Okay, so today I'd like to introduce my guest. Michelle, hello.
Hello, good afternoon.
Oh, it's good to see you. This is Michael Küppers. He is project scientist with the European Space Agency's Planetary Defense Mission, Hera. And this mission is due to launch next week. It's going up from Kennedy Space Center. Is that right, Michelle?
Yes, that's correct. That's correct.
Kennedy Space Center in Florida. We're so glad you're here, and we're so glad you're working to protect us from asteroid collisions. So thank you for both of those things. And, it's strange because we thought we had settled that whole asteroid colliding with Earth thing back in 1998 when this movie came out. What the heck?
Well, yes, if you watch Armageddon and also Deep Impact, then you could think Bruce Willis can do it for us. But
right.
but yeah, it's still fiction. But now we are at the point that for the first time we are demonstrating that we really can do it. That we really think we are able to do it. Should an asteroid approach Earth one day?
And so scientists have been talking about this at workshops and meetings for decades, right?
That's true. And actually, maybe things like Armageddon have maybe helped that it got support because they made the whole threat popular and kind of brought them up to the public's mind. And not only Armageddon, also things like the Shoemaker-Levy 9 collision with Jupiter are those things I think that have made the public aware of the threat and may actually indirectly contribute to those things being funded afterwards.
Yeah. So things do collide with other things
Yes.
out there. Oop, I got to go backwards one. Nope. I'll go to this one.
Okay.
Okay. So the Hera mission. The Hera mission is the follow up to DART. Oh, I know what we're going to do now. I know whether there was a blank there because we're going to watch a clip. We're going to watch a clip from the DART mission. Jeremiah, are you ready to roll that clip? I'm going to stop sharing. And let's look at this for a second. This is a 40-second clip on the DART spacecraft crashing into the asteroid moon Dimorphos in 2022. And so Dimorphos is part of a double asteroid system. That asteroid in the front is called Didymos. And the DART spacecraft had traveled for a couple of years, right, Michael, to get
Right.
to.
That spacecraft, yeah, it was about a year to get there. And I actually have to give credit also to the colleagues from the
Okay,
DART
wait, here it
mission.
goes. Oh. Boom. Crash.
Yes.
That was so cool. That was about the most exciting thing I think I've seen, and I've been watching the space program for 50
Yes,
years,
yes.
so that was exciting.
Yes, and I was just going to say, I mean, I have to give credit to the colleagues on the DART mission that this was basically live streamed to the public. So as the images came down, you could see, well, not the impact, but you could see the last images of that really, really live. And I found this also extremely exciting.
It was so exciting, and it was just so amazing to see DART crash into that asteroid. So that is the first time that humanity has ever, in 2022, despite the 1998 movie, 2022 was the first time that we ever crashed into an asteroid. And so, what happened when we? I mean, did it work? Did we move it?
It worked perfectly. We moved it. The orbital period of the asteroid moon of Dimorphos around Didymos was reduced by half an hour, so from a little bit of 12, below 12 hours to below 11 and a half hours. So from this, we know that we moved it, we gave it a push, and we also have seen that it was a really big effect. We have seen all this ejecta coming out. So it was really a big impact in the double sense of the word. And so yes, it was highly successful.
Yes.
No.
And so if that asteroid had been on a collision course with Earth, would that little push have been enough to deflect it from our path?
It depends on the lead time. So
The lead
for
time.
yes, because one thing that is different from the movies, such a push would not be given last minute. It's impossible in terms of the because of the momentum that would be needed. We would try to give this push years or decades before the actual impact happens. And so with the dart impact, I think we would need, let's say, even something around 100 years to make something not hit Earth. So if something like that would
Wait,
happen, we
did
would,
you say 100 years?
yes,
100 years.
yes.
Whoa. Okay.
And so in the real case, and if just to say something, we would have 10 or 20 years, you would either take something bigger than that or a series of several darts to make
Oh, I
sure
see.
that the deflection happens.
Okay. So still 10 or 20 years. So if we had a year, if we knew a year in advance that an asteroid was coming our way, I mean, it's conceivable, right, that we could just fire everything we had at it? Yes
Uh,
or no?
uh, I would tend to say no, simply because a year is really little to get a space mission ready and
I
to
see.
launch it. Now, okay, I don't know all the capabilities that the military has, but from what I know, I wouldn't expect it to be possible with a lead time of only 1 year.
Okay, but it's hopeful that we're at least working on this, and as time goes on, maybe that lead time can be shortened.
Yeah, and the other thing is, it's not only about the deflection. What the planetary defense offices of both ESA and NASA are working on also is the detection and the follow-up. So the idea is to detect all the asteroids roughly the size of Dimorphos and larger within the next 10 years or so, or at least 90% of them, so that we really know with enough lead time that an impact will happen.
And so, yeah, for some reason, I thought we had already detected asteroids. How big is Dimorphos?
Dimorphos is roughly 150 meters.
Okay, so I had thought that I had heard that no large asteroid was headed for Earth, that we knew that no large asteroid was headed for Earth in this century. But is that
Okay.
not correct?
Um,
Guess it depends on
yeah,
what
no,
you mean
it's
by
not completely
large,
correct. So we don't know any asteroids that's heading towards us.
right?
This is true. Then for asteroids that are larger than, yeah, let's say a kilometer, we
Right.
also think that we are complete for the near Earth asteroids. I mean, we are complete. So we also know that in the foreseeable future, none of those will hit. For those, the size of Mars is basically the size of Dimorphos, 100, 200 meters and larger. We are still incomplete. We are at something like that we know a third or half of the objects or so. So we do not know if one of the unknown objects is heading to us. Having said that, a priori, it's quite unlikely that an impact will happen in the next 100 years.
Wow. So I feel better, but because we have a chance to do stuff, figure things out, and so that's what Hera's all about, isn't it? We have a second mission now
Yes,
that's going to
Hera,
that same system, the
yes,
same
exactly. And
Dimorphos
Hera
system.
is essentially about finding out what happens there in detail and then being able to extrapolate the data results to another asteroid, should it be needed at some point.
Yes, but it's not going straight to Dimorphos. It's swinging past Mars. What's
It's
that all
true.
about?
It's swinging past Mars to reach Dimorphos. And the background is other than that, which was an impactor. Rosetta will going to in rendezvous with the asteroids. So it does not only to reach them, but it also needs to match their velocity.
Oh,
And that's somewhat more complex. And therefore, to reach that, part of this velocity match will be done with the help of mass, which somehow changes the velocity of the Hera spacecraft when it passes by.
so there will be a gravity assist from
Exactly, it's a
Mars.
gravity assist from Mars.
Yes, and basically Hera just gets into Mars's gravitational field, but then sweeps back out again on a
Exactly,
different
exactly,
path, going
exactly. Yes,
faster and in a different
yes,
direction.
yeah.
Yes. Okay, great. So is it going to be looking at Mars at all?
Yes, we are going to looking at Mars,
Oh,
mostly for calibration, and we are also taking advantage of the Mars flyby to get a flyby of close flyby of Deimos, of the moon of Mars.
Oh, okay. That would
So
be
the
interesting.
Hera flyby passes close to the orbit of Deimos,
I see.
and then the flyby will be either accelerated or decelerated to make sure that Deimos is also at the right position when we be there to get really a close approach to Deimos.
And Mars has two moons. We pronounce that Demos,
Deimos, okay.
kind of like the word
Yeah,
demon, Phobos and Demos. I think it means fear and
Deimos,
terror.
okay.
Yeah, and you're talking about the smaller moon, correct? Demos is the
Yes,
smaller
I'm
of the
talking
two
about the
moons,
smaller one, about Deimos.
right? But they're both kind of asteroid-like.
They are asteroids that, I mean, it's still debated if they are asteroids that were caught by Mars or if
Uh-huh.
they are pieces of Mars that were ejected.
Okay, okay. And so we have that mission, but then eventually,
Yes.
how long will it take to get to Dimorphos?
So from launch to arriving at Dimorphos is about 2 years.
Oh, 2 years. Okay, wow. And so this image is showing this red line going down to what, if you look really closely, you can see there's a crater, and that
Yes.
crater is a human-made crater on Dimorphos. We made that crater.
Yes, I mean we have to see if we actually made the crater
Yeah.
or if the impact was much stronger, so that instead of making a crater, it really deformed the whole asteroid. This is one of the things we'd like to
Wow.
find out with Hera. And yes, this image, what it shows, is essentially one of the instruments on board, which is a small laser.
And so let's talk for a second. And so DART came along. We saw that video of DART striking this smaller object here, this little asteroid moon, Dimorphos, in 2022. And now Hera is the follow-up to DART, and it's going there too. And there might be a crater. And you can see in this artist's concept here that there's kind of stuff blown out from the
Yes,
crater. Can we
yes,
talk for a second about that debris? Because you're going to join us back again on, I think it's October 21st, to
21st, yes.
talk to talk about the
Ah,
meteor shower
yes.
that's going to come
Yeah.
from this event,
Yeah.
from when DART
Yeah.
struck this asteroid.
Mhm.
And we here on Earth are going to have a meteor
Yeah.
shower that came from the debris. And it's not going to be this year, but we are eventually going to have a meteor shower that came from the
Possibly.
debris from
Yes.
this
Impact.
spacecraft
Yes.
striking this asteroid. So that's pretty interesting, and it's very interesting, and it's interesting too because when you're sending these spacecraft up here, is there say there was one on the way to Earth and a spacecraft struck it, it kind of sounds like there's the potential to blast that thing into a bunch of pieces and then one of the pieces could hit us. Is that right?
Um, you mean if you have you mean if you have a stronger impact that destroys the asteroid?
Oh, yes. And there's bigger chunks.
Yes. Now, to reach Earth from Dimorphos, you need to be the particles need to be ejected with a velocity of at least about 1.5 kilometers per second. And now the big chunks do not reach that velocity. So
Oh,
anything
right.
that comes to Earth will be small particles.
Oh, that's good.
No, it's to be honest, it's the other way around. I mean, the one question mark on the meteor shower is if particles that reach this velocity are even large enough to create meteors. This is something which we cannot really fully evaluate at this point.
Oh, so we might get a really spectacular meteor shower
Well, I mean,
or not.
it's, no, we are not. I mean, I will need to I maybe need to manage expectations here.
Oh, come
This will
on.
not be. This will not be like the Perseids or the Leonids, because it's just in quotes material that was ejected by a singular event.
Right.
So you cannot compare this to a meteor shower from a comet that continuously emits.
I see. So it's going to be
So we may
very
in the
brief, very
future,
brief.
yes, we may get in the future an enhanced, not necessarily very brief, because the time that it arrives at Earth will be quite distributed.
Oh,
But
I
what
see.
we
It'll
may
spread
get,
out.
it's spread out. Yes, it will be spread out. But what
Okay.
we may get is an enhanced. We will know what we know very well is the direction where those meteors are supposed to come from if they reach Earth. So we may get some enhancement in that of the meteor of overall meteor flux from that direction at certain points in time or in certain time periods. But it will. I wouldn't expect a spectacular meteor shower like the Leonids or the Perseids. Yeah, I would.
Oh,
It will be something more gentle.
darn. Okay. Well, let's talk about Hera. So, what's Hera? Hera is firing. So, in a couple of years, Hera's going up, by the way, on it's scheduled for Monday, but
Yes,
is the rocket that it's supposed to go up on, the Falcon 9, has been grounded by the Federal Aviation Administration
yes,
for the past, I don't know,
yes,
week or two.
yes.
And it at this moment has not been ungrounded. Is that right?
That's right.
It's
We are
still grounded.
waiting. We are waiting on the decision by the FAA to unground it. Now, as far as I can tell, Hera would not be affected by the anomaly from the flight from Saturday last week. Now, currently we are following with the preparations for launch. So today, Hera is being encapsulated in the launcher, and also on Sunday, the launcher will be rolled out to the launch pad. And the launch will go ahead on Monday if the permission from the FAA arrives by then, essentially.
Okay, so you're going to, all systems are go at this
Yes, all
point.
systems are go. I mean, the spacecraft and the rocket are ready for launch. All systems are go. And then if the launch goes ahead on Monday, depends on if the approval from the FAA will be ready by then.
Okay. And so if the FAA does unground the Falcon
Yes.
9 rocket, then the Hera spacecraft will go up on Monday.
Yes.
Yes. Okay. And you're coming. You're in Spain now, but you're
I'm in
coming.
Spain, but I'm traveling to Florida tomorrow. Yes.
tomorrow. Well,
Yes.
safe, happy travels.
Thanks.
So tell us what Hera is going to do. What else is it going to do when it gets after it launches and when it gets to
Yes. Okay. When
Dimorphos?
it arrives at the asteroids, first it will get has some what we call early characterization phase, so to get the global properties of the asteroids, the mass, the shapes, and so on, to know enough to get closer. Then Hera carries two CubeSats with it, and then those CubeSats will be released,
Oh,
and they will do their own independent investigations of the asteroids.
wow. Are they
And
going
this
to
is
orbit
something which is
around the
really a
asteroid?
first. They are also going around the orbit around the asteroids, and will be essentially the three spacecraft will be, at least for a large part of the mission, autonomously orbiting around the three asteroids.
Those
The two
CubeSats.
asteroids, I'm sorry.
Oh, and so is and so Hera, I assume, is going to be orbiting Dimorphos also?
Well, they are orbiting both asteroids. The asteroids are just about a
Orbiting both.
kilometer apart, and so the
Okay.
orbit will be around both.
Oh, that's going to be so interesting. So, and then the CubeSats will also be orbiting both?
Yes, yes. The
And
cube,
how
that's the
long
same.
will will those three, well, the CubeSats are so tiny. How big are
Yeah.
they? They're little
The
bitty, right?
CubeSat, well, the CubeSats are what we call 6 units, and the unit of a CubeSat, well, there are two versions, and ours are what we call XL. Each unit is 12 times 12 times 12 centimeter. So the
Okay, so
CubeSat,
they're bigger than a bread box.
yeah, they are 36 by 24 by 12 centimeters.
Ah, I see. But
Which is still,
still,
if you look at them and you think it's an independent spacecraft, they're really, still really small.
yes. Well, when you think about the distance that they have to
Yes.
travel to get there, it's pretty amazing. So, okay. And that is an amazing technology, those CubeSats, that they're able to carry those things up there. And so, for a while at least, we'll have three spacecraft, the Hera spacecraft and the two CubeSats, will be orbiting these two asteroids.
Yes,
That's that's
that's
very
the
cool.
plan, and the tube that also have their own instrumentation. So it's really two more independent spacecraft that we have there.
And so, what is it that Hera is finding? What are you looking for that's going to help keep us safe from
Yes,
an asteroid collision?
there are simply three major aspects. One is to determine the mass of Dimorphos, the mass of the moon. And this is needed essentially to know how efficient the impact was. What I mean with efficiency, I mean the impact, the velocity of the asteroid is changed essentially once by transferring the momentum of the impacting spacecraft on the asteroid, and then you get a secondary effect from the essentially from the reaction force of the material that's ejected
Wow.
from. And to know what the contribution of that was, you need to know the mass of Dimorphos, to know essentially how much the impact effect from the spacecraft is enhanced. You need to know not only the velocity change to Dimorphos, but also the mass. This is one aspect to know the efficiency. Another is we have a unique opportunity here. We have know many craters on asteroids on the moon, but here we have the unique case that we exactly know what has impacted there on Dimorphos, that we don't know for any of those other craters. So now looking at the outcome of the craters, that helps us a lot to really understand the physics of these impacts, to improve our models of impacts, to really know which kind of impactor creates which kind of crater or impact outcome. And concerning the impact outcome, we don't know if it's like in this artist's impression or if really the asteroid looks completely different because the impact was near catastrophic in that case.
And so, the information that you're getting from Hera is just going to let you refine your knowledge of what happened when Dart hit, and that's going to make us better at hitting the next asteroid more precisely
Yes, I
in the
mean
way that we.
that told us that it was that we can do a kinetic impactor, and it told us that it managed to move Dimorphos to give a certain velocity change to Dimorphos. What we now, the missing pieces that Hera now is one, how efficient was it? I mean, how was it? Was the ejector 10% of the dart impact? Was it the same, or was it 5 times more? Now, from the results we have, and with some reasonable assumptions, what could be the density of Dimorphos, it's probably this secondary effect was probably larger than the direct impact. But it's still something between a factor of a little bit above 1 and 3. It's still within the possibility. So this is something we want to nail. And then both, we want to understand well the impact and also characterize the properties of those asteroids to be able to extrapolate the results of Hera to another asteroid should we one day need it for something that's really on collision course with Earth.
Right. Wow. Well, I am excited about this mission, and I really wish you all the best with it. We did have one question about the meteor shower. I knew we'd get questions. When that story came across our desk, which was a couple of weeks ago, we were all asking each other questions about it, like, ah. And so this person who's watching us wants to know, what will the new meteor shower be called? And they also want to know, will it happen every year?
Okay, the first thing, I'm not sure. It's normally called according to the constellation where it comes from.
Yes.
And in this case, it was a little known constellation whose name I've forgotten now.
Oh, okay. Southern Hemisphere, maybe.
Yes. And the other thing is because it's so special, there are also some speculations that it may be decided to call it Dimorphoids instead.
Oh, right. They
But
did
this is
that.
really
They've done that
speculation so
before.
far. They've done that before, so it's not so clear so far. And well, it's also if there may be something every year, but due to essentially Earth is probably not flying every year through the really. I mean, it will cross it somewhere every year. It will not fly every year through the, let's say, through the enhancements of the flux. So there are certain years where that may be more promising than others in the future, and most of them are a few decades ahead. It starts with the first opportunity maybe like 7 years from now.
7 years from now, I was just going to
So no,
ask you
not
that.
from now, from them. So 2029, 30.
Oh, 29 years
30.
from now.
No, 2029, 2030. I'm
Oh,
sorry.
2029. Okay.
2030.
Yes. Okay. 2029. That works. We'll be around. We'll be around in 2029.
Yes, we will be around, hopefully.
Yes, hopefully. Okay. Michelle, thank you so much. This was super interesting. We really
Thanks to
appreciate
you.
it. Oh, I've been speaking with Michael Küppers, who is the project scientist with the European Space Agency's planetary defense mission Hera. Hera launches, well, we hope it launches on October 7th.
Yes, the launch window opens on October 7th.
There we go. The launch window opens on October 7th. We hope you'll join us again tomorrow to talk about the X9 flare that happened earlier today. We'll be here tomorrow at 12:15 Central or 17:15 UTC. And we'll be back on Monday to talk about the two comets that might become visible, two comets in 1 month in EarthSky. So one Earth, one sky, EarthSky. See you then.